Welcome to Constraint Management, Module 4, Management Science 352. Our journey continues. Let's recap to see where does this constraint management thing fit in the overall Management Science 352 Operations Management whole. Yes, you may notice there is no skip recap button here. You must listen to this. This is extremely important. We started our journey talking about forecasting. And forecasting is where we're trying to predict demand, we're trying to predict prices, right? Using a variety of tools, some of them quantitative, some of them qualitative, but our goal is to predict demand and price primarily. Right? And that's important because it allows us to allocate or start the process of allocating firm resources in the most efficient way. Constraint management continues on with that process. So we went from forecasting, what do we think we're going to sell? How much of it do we think we're going to sell? What prices might we be getting for this stuff? Then we moved into project management. Project management can kind of, we're building buildings or building factories or putting together machinery. But that's part of project management, but that's not the whole part. The biggest component of project management is that we're organizing activities in the production of services or goods. That's it. Right? So we're organizing activities. That's what's kind of fun, right? We're organizing those activities. So we're forecasting what things we think we're going to sell, products and services. Then we're starting to figure out, how do we produce those products or services, or how do we provide those products or services? And now constraint management is exactly what the title means. There's a constraint. Every firm has limited resources. Heck, the planet has limited resources. Okay? Not a big surprise. What we're trying to do is take those limited resources that the firm has, or the government has, or whatever you're working for, and allocate them in the most efficient way possible. And that's what we're going to start to do with constraint management. We've already decided how we put things together. We already decided we have some data on how much we think we're going to sell and what prices we're going to get and pay for things. Okay, so those were all set out, and those tools, we sort of got a general sense for them in the first couple of modules. Now we start to, now we've got a selection of products and services that we can offer, but we only have so many resources in order to provide those products and services. And now how do we provide those? Which products and services do we provide? Okay, so we've moved past how do we make them. And now we're into, which ones should we make? And how much of each product should we make? Because again, the firm has limited resources to make this stuff. And even in the end, if we have all the resources that we need to make to meet market demand is still a resource. There's only a limited amount of our product or service that the market is willing to purchase. Okay, so constraints, very important. If you took Finance 113, soon to be called Management Science 113, we did linear programming, product mix, that kind of thing. It's essentially constraint management. Looking at it from a slightly different angle, but it was essentially constraint management. Okay, so constraint management, just our next continuation in our operations management experience. All these modules, they're all connected to each other. Okay, subterms. So what is the process? And we talked about this, and we saw this in project management. We've got certain inputs, and whether they're labor, machinery, raw materials, whatever. Yeah, and we transform them. That's what we were talking about in the project management component. And then we have some outputs that go, and those go to our customers. Those outputs can easily be inputs for somebody else. So we look at that transformative process, which we discussed in project management, and now we look at which ones, right? Which ones are we most concerned about? Okay. So a constraint is anything that limits us. So if it limits us, restricts our output, it's like life. Anything is a constraint is anything that keeps us from doing what we want to do. And typically in a business environment, what we want to do is provide goods and services, because that leads to more revenue and more profits and so on. And more happy customers, right? I mean, I'm an economist, so sometimes I look at it, hey, there's sort of a utility to the customer getting these goods and services, and the customer's out there trying to maximize his or her utility. And we allow that facilitation by providing those the goods and services that customers desire and need. So we have a constraint. So those are things that limit us. We don't have enough labor. We don't have enough raw materials. We don't have enough machinery. We don't have enough space. We even if we overcome all those things, there's a limitation called market demand. There's just only so much of our product and services that the customers will purchase. Okay. Then we talked about that 2 seconds ago. Capacity is the maximum rate of output of a process or system. Okay, so it's a rate, and it's usually rate in terms of some amount of product per some time unit. Okay, so that's important, and we see that at the very end. It's units per time. Okay, anytime there's a rate, it's a flow measurement. It's so much per time. Okay, so a cashier can serve 20 customers per hour in 1 hour. Okay, capacity of a server, this would be a computer server, of course, 30,000 hits per minute. You can assemble so many hamburgers per minute, so on. Only so many customers can go through a teller over some time frame. I can only mark so many exams per hour, then my eyeballs fall out. Okay. So we have a sort of a little bit of a dichotomy or a rivalry, if you will, between the design capacity for the process, whatever that process is, whatever that system, that project, well, we call it a project in project management, but whatever that system's willing to produce, there's how much it's designed to make. And then it's really the effective capacity, how much does it actually produce? And not surprisingly, they're often different. Not a big shock. Nobody's going to be design. The theoretical capacity and the actual capacity, they're different. Ooh, didn't see that coming. That's a shocker, isn't it? But they are. Okay, and there's a variety of issues that could be at play. One of the biggest ones is that the demon of Management Science 352, variability. No. Yes, variability is back. Right, screws everything up. Sometimes machinery it works a little bit better. Sometimes the gremlins get in there and something breaks down. And so we have breakdowns. Okay. And equipment breaks down. All of a sudden, hey, your theoretical your theoretical capacity is, that's all great, but that doesn't allow for the fact that this piece of equipment is now broken. Or people are variable. Some days you have good days, some days you have bad days. Some days you write good midterms, some days you write bad midterms. Right? There's variability in people performance as well. Some days you're happy and go lucky. Some days you're burned out because you've been strapped to a screen for 20 hours. Okay, so lots of things go into why effective capacity is typically lower than design capacity. I.e., the real world sets in. What else do we have here? So bottleneck. So bottleneck is kind of like we had critical path, right? We had the critical path in project management. That's like the bottleneck here. Okay? So they're connected concepts. Okay? The critical path, when we were talking about project management, dictated how long the project would take. Well, the process, the same stuff. Potato, tomato, right? Project, process, doesn't matter. Okay? So that project or process took a certain amount of time in the project management unit. Guess what? It's now Mr. or Mrs. Bottleneck or Ms. Bottleneck or Master No, can't say master. That's politically incorrect. Used to be in the old days when you had the little young one, usually young male, say master such and such. Now you can't. So we have the bottleneck, very similar to the critical path in project management, right? And it is that thing, that activity maybe, that whatever that constrains us. Okay, anything, it limits us, just like critical path limited us, right? So it's something that's limiting us doing more of what we want to do. So let's look at cooking hamburgers, because that's something we sort of all relate to. In sometimes in some of the assignments that you may be doing is full laundry, making hamburgers is a good one. So let's look at it. We got raw material, right? The hamburger. We cook it, we assemble it, we deliver it. Okay, so very simple process, right? Right? Kind of looks like a project too, just oof, very simple one. Okay. And we have some data, some measures, right? The patties cook in 60 seconds. Okay, the stove holds 20 patties, so we have some idea of how much we can produce in a certain time frame. Okay, assembly of the hamburger takes 27 seconds per hamburger. Okay, but 10 workers are available to assemble the hamburgers. What is the capacity of the cooking stage? What is the capacity of the assembling stage? And what is the capacity of the process? The capacity of the process is a very similar idea to the duration of a project. Right? It's limited by, the duration of a project was limited by the critical path. The capacity of the process will be limited by the bottleneck. So, very connected thing. So we're going to make our hamburgers here. We're going to assume we have only one stove, one cook, but 10 workers doing the assembly. So we start off our process with an order of 60 hamburgers come in. Let's map this out. There are a variety of ways to map it out, but we'll just use it with a simple timeline without getting too complicated. There's all sorts of more involved tools that you could use to sort of express this relationship. We'll just try to keep it simple, but just be aware that there are more sophisticated tools to map these things out, because there are often more sophisticated processes here. But we're still learning. So we have our assembly, we have our cooking, and then that's basically our two activities, right? So first thing is, well, we have to, in our precedence relationship, we have to first do the cooking. Okay, so onto the stove. First 20 patties go there, okay? And they're cooked up in a minute. Now, clearly it makes common sense that you can't assemble any hamburgers until you actually have hamburgers to assemble, right? Till the patties are cooked. So in the first minute, we're just doing the cooking process. Then, once those go off, we can then, off the first 20 hamburgers off the stove, and they're done, or off the grill and they're done, and then we put the second 20 on, okay? And they'll cook until 2 minutes. Okay, so there's our cooking stages going. Now, whilst we've taken the first 20 off, they go off to be assembled. So those 10 people assemble the first 10 hamburgers, and that takes them 27 seconds, and so they're done at minute 27. And they roll over, each one of them. Now, presumably they're working at an equal pace, they're equally skilled and so on. Big assumption. So you can see where design capacity and effective capacity can deviate here. And then they do the next 20, and then boom, 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 boom. They're all done, minute 54. Now, it takes us until 2 minutes for the second batch to be ready for those assemblers to kind of hit those hamburgers again. So they've got like 6 seconds of slack time here. So slack time, ooh, I remember that from project management. Same kind of idea, right? They got an extra 6 seconds where theoretically they're not doing anything. However, if there's a little bit of variability in the assembly process, we can perhaps do deal with that variability without assembly becoming the new bottleneck and restricting throughput and output and all that kind of good stuff. Okay. So, second set of hamburgers come off. Boom, we take them over to the assemblers. We put the third set on. That will take to the 3 minutes, and then the other folks are going to assemble the next set of 10 hamburgers, and that takes them till 2:27 because they can't start till minute 2 when the second set are done. And then once they're done that, they roll over to do the next set, and so they're again done at 2:54. So you're kind of seeing that there's this 6 seconds of extra time in every minute for the assembly process, or the assembly activity. Okay. Oh, we're only trying to place an order for 60 hamburgers here, so no more hamburgers are going back on the grill, and they just assemble them, and we're all done at 3 minutes and 54 seconds. Okay. Now, if the process continues, how many hamburgers do we produce every minute? So when we talk about that, it means we're already sort of in some set of equilibrium. Okay, so the process has started and is now in a, for lack of a better term, because I'm an economist and I can't split that away from. We're in a steady state. Okay, that means assemblers are assembling and cooks are cooking. Okay, and we're not talking about this initial startup point any longer. So looking at life from minute 1 beyond. And we just keep pumping out those hamburgers. Well, what do we notice? Well, I can do, looks like I'm limited to being 20 hamburgers per minute. Right? Takes a minute to cook the 20 patties, and so we can see that that's a little bit of a capacity. However, the assembly is a little bit different because it doesn't take the full minute to assemble those 20. So I can assemble 10 in 27 seconds. How many can I assemble X in 60 seconds? Ha ha! Ratio. How? Oh man, I was trying to remember the Shakespeare quote. How are you, fair ratio? And so we can produce slightly more than 20. In theory, if we had more hamburgers, we could produce more. We could assemble more than 20 hamburgers per minute. And if you do the ratio, 10 to 27 seconds, X to 60 seconds, solve for X. Convert that into, and you've converted into a minute process, you will see that you can do 22.2 hamburgers per minute. Okay. The bottleneck resource is the one that puts out the slowest amount of hamburgers, which would be the stove or the grill. Okay. So pretty cool, right? Okay, a couple of more definitions, and then we're done with this little segment. Utilization rate is we take that throughput rate, how much the capacity that we used, divided by the capacity. So, for instance, when we were looking at the hamburger, the cooking, right, we're operating 100% of the time. We can do 20 hamburgers per minute. We are doing 20 hamburgers per minute. Full capacity. For the assembly, we can do 22.2, but we are doing 20. So 20 divided by 22.2 gets us the capacity for the assembly activity. Okay, just to be clear. Okay. Look at it. How much we used for assembly, for instance, was 20. How many did we have? We had 22.2. There you go. Usually it's expressed as a percentage just so that it's easily understood. Proportions, for whatever reason, seem to be more awkward for people to work with. And percentages we're more comfortable with, so we're in a communication field, of course. So we usually express that as a percentage so that our wide audience of stakeholders that we're reporting to understand what it is that we're talking about. The throughput rate is the average flow rate through the system. Okay, number of jobs per unit of time, 20 hamburgers per minute kind of thing. To time, start to finish, right? That's like duration of a project. Right? So depends what our start to finish are. Right here, we made 60 hamburgers, start to finish, 3 minutes and 54 seconds. If the process is ongoing, then we could pick a slot of time and look at throughput time. But typically, in the burger case, let's say we had one big order come in for 60 hamburgers for a picnic or something like that. And that would be our job, 3 minutes and 54 seconds to get those hamburgers cooked and assembled. Okay. Utilization rate is a measure of efficiency, so we do like to be as high as possible. Not necessarily that 100% is some sort of golden standard, because at 100% it means there's little scope for any kind of variabilities or breakdowns, and there could be a negative connotation to that, right? And so we want to keep an idea that we prefer that utilization rate to be as high as possible, but little bit of judgment in the sense that 100% is not necessarily the golden standard. 100% could be non-ideal because it doesn't give us enough time to deal with any kind of variability or unforeseen issues, and therefore if you're going at 100% of utilization, you could miss out on a customer order, and you have a customer satisfaction problem because you didn't deliver their order on time because you just had no spare capacity. Okay, so the capacity of a cashier in Starbucks, for instance, 96 per shift. Throughput rate, 72 customers per shift. Capacity utilization is just the 72 divided by the 96. Okay. Now, they're busy with customers 75% of the time, but that's sometimes not their only set of tasks, right? So for anybody who's done worked at Starbucks before knows that there's other things you need to be concerned with as well, as is the case if you're dealing with customers in any sort of position. There's other aspects to your job than customer service. I mean, customer service is it can be the most important part of your job, and certainly customers are extremely important because there's nobody, if you don't have revenues coming into the firm, clearly there's no money for anybody else, whether you're a lawyer, an accountant, or a salesperson. So dealing with customers can be the primary activity, but there's also other tasks. And so now we can kind of see that is 25% of the cashier's time a sufficient amount of time to do those other tasks that are typically supportive of the sales function in this particular example. Now, if we find out that there's not, then that's where we start to think of, do we have a sufficient number of employees working at any particular moment in time? Okay, one last slide. Just thinking throughput time, just thinking any service, anything, go to the bank, right? You arrive at the bank, you wait in your socially distanced line for your turn at the teller or the ATM for that matter. The service begins, takes a little while to do the service, whatever it is, getting money, putting money in, taking money out, and then the service ends and you leave, right? And there's your process. It's like a project. Book at Amazon warehouse, same kind of idea. Okay, and so we have that flow of activities. Okay, next segment we'll deal with facility design, the key concepts. We talked a little bit about this way back in the first unit, so we'll go over it fairly quickly, which I think is a merciful way to do it.